Hello, welcome to Doti Academies. In this tutorial, I'm going to be teaching you how to solve quadratic equations. By considering these three quadratic equations as shown in this video. So the first quadratic equation you have is that of x squared plus 5x plus 6, followed by 3x squared minus 6x minus 27 equal to 0, and x squared plus 10x minus 75 equal to 0. This third example of a quadratic equation I'm going to give to you as an assignment for you to solve. So in these tutorials we have basically there are four methods of solving quadratic equations. The first methods are factorization method, completing the square method, use of the formula, and graphical methods. So I'm going to consider these two example 1 and 2 on factorization method, completing the square method, use of the formula, and graphical method. So I'm going to leave the third example for you to solve as regards. So to start with factorization method of solving quadratic equations. So the factorization method, picking the first example you have as x squared plus 5x plus 6 equal to 0. So with these, you are to consider the coefficient. The coefficients of this quadratic equation. First, consider the coefficients of x squared here is 1. If 1 is coefficient of anything, is not necessarily written, and that's why you don't see 1 in front of x squared. It is 1 x squared, so the coefficient is 1. 1 multiplied by anything will give you that thing. So when you have the coefficient of a square powers to be 1, you forget about it, because if you multiply with your constant, you always have back your constant. So now before we proceed to the coefficient of x, the coefficient of x as regards this equation is plus 5. You keep it at the back of your mind and have your constant to be positive 6. What you are going to do with this story is that you are going to think of two numbers in which when you add it or by subtracting it, either by adding it or by subtracting, you obtain the coefficient of x. By multiplying that same number, you obtain the constant, which is plus 6. So the number I'm able to think of is that 2 and 3. When you say 2 plus 3, you have plus 5. And when you say plus 2 times plus 3, you have plus 6. Which is why I replace 5x with 2x plus 3x, because when you say 2x plus 3x, you have your 5x. A is the x squared, and here you have followed by plus 6, and everything is equal to 0. So in this case, you are going to have to include this in the bracket. X squared plus 2x you include in the bracket, and also 3x plus 6 you include in the bracket, and have all equal to 0. So when you do that, you factorize what that needs to be factorized. Here you have xa. xa is common to the both terms. You factorize x out, you are now left with 1 xa. Since x has been factorized here, you have 2. So here 3 is a factor of 6. So 3 goes in 6 how many times? 2 times. When you move 3 out, you are left with xa. So the 3 goes in 6 how many times? 2 times. Then you have it closed in the bracket. Here you have x plus 2, x plus 2. X plus 2 is common to the both sides. When you factorize x plus 2 out, you are now left with what? X plus 3, everything equal to 0. So s plus 2 is equal to 0, or s minus 3, s plus 3 is equal to 0, because you said this is equal to 0 or this is equal to 0. So when you look at this, also bringing plus 2, bringing this plus 2 to the other side of the equation, you are left with is 0 minus 2. Is 0 minus 2 will give you minus 2. S is equal to minus 2. Or bringing plus 3 to the other side of the equation, you have is 0 minus 3. You have minus 3. So S is equal to minus 2 or minus 3. So again, you have the second equation. The second equation, which is that of 3x squared minus 6x minus 9 equal to 0. When you look at this, you consider the coefficient of x squared. I've said earlier on, the coefficient of x squared is 3, is not 1. So when it's not 3, what you are going to do with it is you multiply with 9. So 3 times minus 9 will give you minus 27. You keep minus 27 at the back of your mind. Then you keep asking the question that the coefficient of x here is was minus 6. Then you ask the questions like, what is that factors? 2 factor. You think of 2 factor, in which when you add this or by subtracting it, you have minus 6. By multiplying that 2 factor, you have was minus 27. You keep at the back as the product of 3 times minus 9. What is that factor? Here I'm able to produce minus 9 plus 3. When you say minus 9 plus 3, you have minus 6. Minus 9 times 3, you give you back minus 27 as a factors of the quadratic equation. These satisfy the quadratic factors. Therefore, we proceed and enclose these two in bracket. 3s squared minus 9s. You obviously close in the bracket again. You have plus 3s minus 9 plus 3 plus signs on necessary put when it begins its statement plus 3s minus 9 equal to 0. So having arrived at this, then you factorize all that needs to be factorized. When you come here, you see 3 is a factor of 9. You bring 3 out. Also, you can find s here and you can also find x here. You bring s out here. The 3 has been moved out and 1 s, you are left with one single s minus 3 goes in 9 how many times? 3. Then the x has been moved out, you are left with x minus 3. Again, when you come here, you have 3 here. 3 is a factor of 9. You bring 3 out, you are left with 1 s and 3. 3 goes in 9 how many times? 3. Here you have s minus 3 to common to the both times. You factorize s minus 3 out, you are going to be left with 3x plus 3. This implies that 3s plus 3 is equal to 0 and 3s minus 3 is equal to 0. So 3s plus 3 here equal to 0 or 3s minus 3 equal to 0. So you consider taking plus 3 to the other side. You have 0 minus 3, you have back minus 3. You have 3s is equal to minus 3 or 3s. When you bring minus 3 to the side of the equation, you have 0 plus 3 as 3. You have 3s is equal to 3. You consider divided the both sides by 3. 3s is equal to minus 3. Divided both sides by 3, you have s is equal to minus 1. Divided both sides by 3 here, you have s is equal to 1. So here is the factors of the quadratic equation. Therefore, I'm going to consider another approach, which I call the completing the square method of these two quadratic equations. The third example of the quadratic equation I'm going to give you as an assignment. So now consider this completing the square method. In completing the square method, what you are going to do is, first of all, you transfer the constant to the other side of the equation. Here you have the constant to be pluses. When you bring pluses to the other side of the equation, you have 0 minus 6. You have it back as minus 6. Here you have s squared plus 5x is equal to minus 6. So what you are going to do next is take the coefficient of s. The coefficient of s is 5. You take the coefficient of s and you divide it by 2 and you square whatever, everything squared. This is where the completing the square method is having its name. 5 over 2 everything squared. 5 the coefficient of s divided by 2 and square it. So therefore what you are going to do with this is add it to that equation. Since you have used the coefficient of s to obtain this, there is no need of writing the coefficient of s. All you have to do is write back your x. So the coefficient that you've used, then you write it. This is what you obtain of the coefficient of s, then you add it to this side of the equation. This is one side of the equation. Therefore you have s squared plus 5 over 2 everything squared is equal to the minus 6 is this side, and then you had also 5 over 2 all square. Since this is in squaring, this is also in squaring, you can have it included in one squaring bracket, and is equal to minus 6. 5 square is what? 25, and 2 square is what? 4. So the next thing you are going to do is simplify this. To simplify this, you consider this as minus 6 over 1. So the LCM of 1 and 4 is 4. Then you ask the question like, how many 1 can be found in 4 is 4. 4 times 6 will give you back minus 24 plus 4 in 4, 1 times 25, 25. Again, you have s plus 5 everything squared to be equal to minus 1 to 4 plus 25 is equal to 1 over 4. Then you consider taking the square roots on both sides in order to eliminate for the squaring. To eliminate for the squaring, you consider taking the square root on both sides. Taking the square root on s plus 5 everything square, you have that equal to the squaring. We cancel the square root of 1 over 4 here, as you can see. So now the squaring cancel the square, you have s plus 5 over 2 plus or minus the square root of 1 is 1, the square root of 4 is 2. Then you bring plus 5 over 2a. So you have s is equal to minus 5 over 2 plus or minus 1 over 2. So this implies, consider that taking the LCM is also implied minus 5 plus or minus 1 over 2. So the meaning of plus or minus sign is implies that s is equal to minus 5 plus 1 over 2 or minus 5 minus 1 over 2. So minus 5 plus 1 is minus 4, and the minus 5 minus 1 is minus 6. When you divide it by 2, you have the result of the quadratic equation to be equal to minus 2 or minus 3. So the next example I'm going to consider is the second example, which I have as 3s squared minus 6s minus 9 equal to 0. I'm still going to have to consider the completing the square method of solving quadratic equations on. So now taking the bringing minus 9 to this side of the equation. So when you bring minus 9 to this side of the equation, you have 0 plus 9, which is going to give you plus 9. Now you have 3s squared minus 6s is equal to 9. So you divide all through by 3, the coefficient of s squared. The next thing you are going to do, divide all through by the coefficient of the square. When you divide all through, you have 3s squared divided by 3 minus 6 divided by 3 is equal to 9 divided by 3. So 3 cancel 3, you have s squared minus 3 cancel 6, you have 2, and 3 goes in 9 3 times. So the next example is to take the coefficient of the x. The coefficient of x we have as minus 2. You are going to have to divide it by 2 and square. It's just as we have done in the earlier examples. You take the coefficient of s, you divide it by 2 and square. The coefficient of s is minus 2. You have it divided by 2 and square. It's minus 2 over 2 will give you minus 1 square. So what you are going to do with minus 1, you are going to add it to the both side of the equation, neglecting minus 2s, because minus 2s is used to produce minus 1. So here you have s squared my plus, then you have the plus, minus 1 square is equal to 3 plus minus 1 square, as you can see, plus minus 1 square. So since this is square, you have to consider taking them in one squaring bracket. Taking them in one squaring bracket implies that you have s squared plus minus. Plus times minus will give you minus. Everything square is equal to 3 plus minus 1 square. Minus 1 square is minus times minus 1 times minus 1 plus 1. So you consider taking the square root on both sides. Taking the square root on both sides is equal to 3 plus 4. You have 3 plus 1, you have 4. Taking the square root on both sides, you have to eliminate for this squaring. Square root here, square root here. The squaring will cancel the square root here. You are left with s plus 1 is equal to plus or minus. The square root of 4 is 2. So now you have x is equal to, you bring plus 1 to this side of the equation, you have minus 1 plus or minus 2. The meaning of plus or minus, I've said, is implied that s is equal to minus 1 plus 2, or s is equal to minus 1 minus 2. Minus 1 plus 2 will give you 1, minus 1 minus 2 will give you minus 3. So now we are proceeding to the next method of solving quadratic equations. The next method of solving quadratic equation is that of I'm going to consider completing the square method of the general terms of the general forms of a quadratic equation. The quadratic equation is an equation which often looks something like this. You have the a as the coefficient of s squared, b as the coefficient of s plus c as a constant, which doesn't have anything with this, is equal to 0. So when you look at that, the first thing you have to consider in any quadratic equation by completing the square method is by transferring the constant to the other side of the equation. Transferring the constant to the other side of the equation, you have taking plus 6 to this side of the equation. You have 0 minus 6, you have that as minus 6. Here you have plus bx as squared. As squared plus bs is equal to minus 6. Then you consider dividing all through by the coefficient of l squared, just as I have done in the earlier example. Divide all through by the coefficient of l squared. You have as squared divided by a, bs divided by a is equal to minus 6 divided by a. As you can see, divide all through by the coefficient of l squared. So a divided by a, you have l squared plus bx over a is equal to minus c over a. So what you are going to do now is to take the coefficient of s. The coefficient of s is what b over a. Divide it by 2 and square it, just as we have done. Divide something by 2, divide a fraction by 2. It's also implied multiply that fraction by half. Dividing anything by 2, it implies that multiply that fraction by half. So you have them all square. B over a is the coefficient of a. You divide it by 2 or multiply it by half. You have a square to be equal to. So when you do that, you say b times 1, you have b. A times 2, you have 2a, everything square. So you are going to do what you are going to do with this is add this to the both sides of the equation, neglecting coefficient of x over a. So when you say l square plus, instead of writing bs over a, you now have this to replace it. You add it to the both sides. You have b over 2a, everything square, to be equal to minus c over a plus b over 2a all square. Now this you've added it to this side of the equation. Now you have added it again to this side of the equation. Since this and these are square, you have to include it in one squaring bracket as s plus b over 2a, everything squared, to be equal to minus c over a plus b is entitled to the square, you have it as b squared. 2a entitled to the square, you have 2 entitled 2 square is 4, a square you have it as 4a square. Again, Having arrived where you say s plus b over 2a, then you consider taking the LCM on the denominator on this side in order to factorize these two together. The LCM of a and a square is what? 4a square. So when you say a in 4a square, you have 4a. 4a times minus 6, you have minus 4ac. 4a square in 4a square, you have 1. 1 times b square, you have plus b square. Then you consider taking the square root on both sides in order to eliminate for the squaring. Taking the square root on this side, you have this. You have the square root there, plus or minus. The square root on this side, you have it. All you have to do here is just to rearrange. Instead of having the minus at the front, then you bring it to the back. You have b square minus 4ac, everything over 4a square. So the squaring, we cancel the square root here. You are now left with what is inside of the square root as s plus b over 2a is equal to plus or minus the square root of, you can have the square root of 4a squared. The square root of 4 is 2. The square root of a squared is a. So you have the square root of 4a squared as 2a. Then you have the square root of the numerator part as b squared minus 4ac written in there. So now you are going to consider taking plus b over 2a to this side of the equation and bring it to this side because you are aimed to calculate for your x. When you bring this to this side of the equation, you have minus b over 2a plus or minus everything that is said, which is b squared minus 4ac over 2a. So you consider taking the LCM on both sides. 2a, the LCM of 2a and 2a is 2a. You have 2a in 2a as 1. 1 times minus b as minus b plus or minus. 2a in 2a is 1. 1 times b square root of b squared minus 4ac will still give you back square root of b squared minus 4ac as a formula for calculating the quadratic equations, which was derived from the completing the square method of solving quadratic equation. The formula is now minus b plus or minus square root of b squared minus 4ac over 2a. I'm now going to consider the third examples. The third method of solving quadratic equation, which is the use of the formula. Consider this formula on it. So the first example I've been dealing with is that of s squared plus 5s plus 6 is equal to 0. So what I'm going to, in solving the quadratic equation by formula method, all you have to consider is the coefficient. I say a squared plus bs plus 6 earlier on. So a is the coefficient of s squared, b is the coefficient of s, and c is a constant. When you look at this particular quadratic equation, the coefficient of s squared is 1. I say 1 if 1 is the coefficient of any factors. It's not necessarily written. That's why I say a is equal to 1. So the coefficient of sa is b, is 5. The coefficient of SA is 5, which is equivalent to B as the coefficient of BX. And C is our constant. So therefore, we are going to substitute all of these coefficients. Plus 5 is 5 plus 6, and plus 1, which is 1. So I'm going to consider the formula for solving quadratic equation, which we derived from the completing the square method earlier, as minus b plus or minus square root of b squared minus 4ac over 2a. So s is now equal to minus b. What is my b? My b is 5. I have minus 5 plus or minus b squared, 5 squared, minus 4. For coming from the formula a times a. What's my a? A is 1 times c, which is 6. So here I have minus 5 plus or minus square root of 5 squared. 5 times 5 is 25. Minus 4 times 1 times 6 is what? 24. Everything over 2a. 2a, that's 2 times 1, which is 2. So minus 5 plus or minus square root 25 minus 24 is 1. The square root over 2 is equal to that. So the square root of 1 is 1. I have minus 5. Sorry, there is a mistake. There is supposed to be minus a. So minus 5 plus or minus 2 plus or minus 1 over 2. So now the minus has been replaced here. You have s is equal to minus 5 plus 1 over 2. The meaning of the plus or minus imply s is equal to minus 5 plus 1 over 2, or minus 5 minus 1 over 2, the plus or the minus, which is why you have this there. So you have minus 5 plus 1 is what? Minus 4 over 2, or minus 5 minus 1 is minus 6 over 2. So s is equal to minus 2. When you divide 2 by minus 4, you have minus 2. Divide 2 by minus 6, you have minus 3. So the factor of the quadratic equation is minus 2 and minus 3, which is exactly what we obtained in the earlier methods of solving quadratic equations. So the next example I'm going to consider is that on 3s squared minus 6s minus 9. I say all you have to consider is the coefficient. The coefficient of the square represented by a is 3 as regards this equation. The coefficient of x is minus 6. Here you have minus 6, and c is a constant, which is minus 9. Using the quadratic formula as minus b plus or minus square root of b squared minus 4ac over 2a. So you have s is equal to minus, the minus coming from the formula, and the b itself is having minus. This is why I have minus into bracket of minus 6 plus or minus the square root of b squared, that's minus 6 squared, because b is represented by minus 6, minus 4a, which is 3, times c, which is minus 9, over 2a, 2 times 3, which is that 3 coming from the coefficient of square 3. See, s is equal to 6 plus or minus 6 squared, that is 36, plus 4 times 3 minus 4 times 3 minus 12 times minus 9, you have plus 108. Minus times minus will give you plus 108. So you have s is equal to 6 plus or minus square root of, because here you have minus times minus, you have positive 6 plus or minus 36 plus 1 square root of 36 plus 108 over 6. So 36 plus 108 will give you 144. The square root of 144, that is s is equal to 6 plus or minus square root of 144 over 6. The square root of 144 will give you 12. 6 plus or minus 12 over 6. So the plus or minus sign now implies that s is equal to 6 plus 12 over 6, or s is equal to 6 minus 12 over 6. So 6 plus 12 will give you 18 over 6. 6 minus 12 will give you minus 6 over 6. 6 goes in 18 3 times, and 6 goes in minus 6 as minus 1. So the formula, this is the end of my tutorial. So in the next, I would like you to make a comment if there is anything that is found that is not right of my tutorial. You always ask questions. Thank you and goodbye.